In this video, we're going to be seeing how to predict whether a precipitate forms or not. Before you can do that, you need to know the skills of calculating KSP from MSP, so you should understand these skills very well. This is a warm-up practice that you can do. I recommend you start with this first and check your work using the answer key that's provided over here. If you have a hard time with this, I'd recommend that you go back to the previous lesson on MSP and KSP and try those skills out before you attempt this lesson here. So our goal for this lesson is to predict whether a precipitate will form when you mix two solutions together. So for example, let's say we have sodium phosphate and silver nitrate. These are two solutions. Everything is dissolved within those solutions there. So ions are all swimming around happily, as you can see from the AQ over here. And they're going to go through a double displacement reaction, as you learned in grade 11. And so the idea is that the cations will switch spots. So the sodium will go where the silver is, and the silver will go where the sodium is. And after our crisscrosses, we get these compounds over here. Now, once we mix them, it is possible that a precipitate forms, and you'll usually see it as this cloudy substance that appears. It's basically no longer soluble in that volume of water, so it comes out of the solution. It precipitates. And if you leave it after a while, it'll settle down at the bottom, almost like sand at the bottom of a body of water. Now, which substance is it in the two substances that have formed here? Well, in order to figure that out, we need to go to our solubility table. So let's go to our solubility table, which is found in your relevant reference section of your course. Here it is. There's different solubility tables that you can use. Make sure you use the one that your teacher assigns. But essentially, we take a look at the anion in our compound that we're interested in. So let's look at the phosphate. So this is silver phosphate. So we're looking at the phosphate as our anion right over here. And it says for phosphates, and all these ions here, alkali metals, H plus and NH4 plus, soluble, all others insoluble. So we're with silver. That does not fall under these categories here. It's under all others. So that means that the silver phosphate is insoluble. So it's a precipitate. So this is actually the silver phosphate. And let's just double check the sodium nitrate. Generally, nitrates are considered soluble. Most nitrates are soluble. So if we take a look here, we have nitrates. You'll see that most are considered soluble. So there's very, very few exceptions. And we don't see any exceptions at the grade 12 level anyways. So this is a nitrate. Sodium nitrate is considered soluble, so that's aqueous. So this is the substance that came out of the solution. The ions of silver, phosphate, and phosphate came out of the solution, and the sodium and nitrate remain dissolved. Now, how do we know if this is going to happen? How can we predict this will happen? Well, we can do our double displacement and look at our solubility table to see if there will be a precipitate, but certain conditions have to be met for this to actually precipitate out. And so we're going to take a look at what those conditions are. To predict if this precipitation will actually occur as is written, we need to use something called the trial ion product. The trial ion product is a special type of Q called the QSP. And what we do is we compare that QSP to the KSP. And depending on whether it's larger, smaller, or equal to KSP, we can predict if a precipitate will form or not. So the QSP is a value that we compare to the KSP in order to determine if a precipitate will form. And we can even determine what concentrations are required for the ions to form a precipitate. So we're going to go ahead and take a look at what the different results of QSP versus KSP can indicate. So if you do your QSP calculation and you get that it's lower than the KSP, so QSP is smaller than KSP, what that indicates is that you have an unsaturated solution and there's no precipitate. That's because your solution is not yet full and you can still fill it with more solute. So you can put more in there and dissolve some more. So if you have QSP is less than KSP, your solution is not yet saturated. You can still fit more into it and you won't have a precipitate. if you get the result that QSP is equal to KSP, at this point, no more solute will be able to dissolve because your solution is considered to be saturated. So this is truly the part where you are at equilibrium, where you have equal rate of dissolving to precipitation. So essentially what's happening is you have some solute dissolving and some precipitating at the same rate. So it looks like nothing is happening. Essentially, you're throwing in more and more solute and no more will dissolve. So that's called a saturated solution. It's when QSP is equal to KSP, and no precipitate will form at this point because you're just perfectly happy and satisfied. You can't fit any more in, but you don't have more than you need. Now, the case where you have a QSP that's larger than KSP, that's where your solution is supersaturated. Your solution contains more of the certain ion than it should have, or certain ions than it should have, and as a result, as soon as you add new crystals, the solution is going to spit out any of those excess ions that were there. So if QSP is larger than KSP, your solution was supersaturated. And what that means is that your solution will now spit out the excess ions that were dissolved in there. And that's when precipitation actually occurs. So using your knowledge of QSP versus KSP, you can predict the degree of saturation of your solution. Is it unsaturated, saturated, or supersaturated? And the only case where you have precipitation is where the solution is supersaturated. So this is where a precipitate will form. So as you can see here, a supersaturated solution contains more dissolved solute than required for preparing the saturated solution. And that can be prepared by heating a saturated solution, adding more solute, and then cooling it gently. Excess dissolved solute crystallizes by seeding supersaturated solutions with a few crystals of the solute. So essentially, as soon as I add one more crystal of the solute into a supersaturated solution, that's going to act as a little seed around which the crystallization can occur and the precipitate can start to form. So when we do a chemical reaction that's double displacement, we need to find what our precipitate could be, and then we need to calculate the QSP for that precipitate given the concentrations in that scenario compared to the KSP, and from there we can determine if that substance will actually form a precipitate. It is possible that it stays dissolved, but as soon as you meet a certain concentration to allow your QSP to be greater than your KSP, then it will undissolve. It will precipitate and form a solid and come out of the solution. So our goal for the next few questions is to compare QSP and KSP to predict if a precipitate will actually form in the given scenarios with the given concentrations. We'll see that in the next video, but for now, it is important for you to understand how to calculate KSP from MSP from the previous lesson, to understand that we're going to be predicting if precipitates will form using the QSP and compare it to the KSP. You should also understand and review double displacement reactions and how to predict which would be your precipitate and which would remain dissolved using solubility tables. And you should understand degrees of saturation. So what does it mean to be unsaturated, saturated, and supersaturated, and how that now relates to QSP and KSP. If you understand those skills, you'll be ready to do the next video, which is actually predicting if a precipitate will form.